Alright guys, here you go. We're doing the Holtz machine at the top. We've worked at the bottom, we've started at the bottom, we've worked all at the top. I was a little bit reluctant to do this because it's basic physics, it's just a Holtz machine. I'm not going to explain it too much, I'm just going to go through it quick. You should have bought this book by now. If you don't know what a Holtz machine is, buy this book. AD Moore does it as a die rod, but the principles are the same, right? It's on this page here, and I'll bring this photo up so you can see it a bit better. But basically, we're inducing a charge. I've put the Holtz machine at the top here. We've got our top off, just undone the bolts. Right, so in relation to this machine here and this machine here, the equalizer. So this is the equalizer. I've just done a ring. Here's my equalizer. Our two parts from coming apart. So I've got a collector on this machine here. This is your collector. This is positive or negative, whatever. This is one collector. This is the other collector. So here's our collector. Real quick. I've pulled this out. I've taken this off the top. This is my equalizer ring. Mine, I've just put a wire in there. And I've joined a mistake with this when I did it. I've used this sticky stuff. And it's broken down. High voltage. It's not sticking properly. So I'm going to go through and peel it off and I'm going to paint it. My edges are probably a bit too sharp here. I've cut the edges a bit sharp. This is where my collector is going to come through. So it's mainly this area here that needs to be, have the metal. Doesn't really need to be here. I can cut this back further out of the road, but wherever that sector is, I want it to induce a charge and I don't want it to leak back, so it has to be well insulated around this edge here, away from my earth terminal. It's been the last thing on my mind, simply because it worked anyway. I didn't worry about it, so it's working anyway. The wire just sticks through. As long as you've got the wire sticking through and you've got a charge on it, it'll jump the gap. It'll jump the gap. So the charge wants to jump off the rotor here, and it wants to jump on the rotor there, so you can have a millimeter gap or a 2 millimeter gap. You don't have to touch. It's just building up the initial charge that you have to touch. So you might have to push the wires in. As soon as it's running, that's it. You can let it go and it'll be fine. So that's what I'll do. I'll go through. I'll paint the plates and insulate it a bit better, and put it back together. It should be fine. I'll clean the edge here, the wire and all the different things I've tried to use to see what would be best. I tried the black rubber stuff, but it dragged, it slowed it. Maybe I should just have a clamp on the side, but they put a screw in it, and I can just tighten it, pull and push the wire to where I want it, and then just tighten it, and that's it. Or even just firm it up, and I can slide in and out. With a hole, it's a bit hard to get it exactly right. So here's the way I did the top of mine. I'm just going to get the paintbrush and paint. I'm going to clean it, and I'm just going to paint, give it one coat of paint around the top in here. I'm not going to touch the outside edge. I'm collecting the charges off the edge. This is the one. I just have a little slider here. I have my wire just sticky taped in there. There's my wire, and it just sprays the charges off the end. And due to the Faraday effect, whatever you want to call it, the charge. Oh. It's not even supposed to be that far in, I pushed it too far in. The charges spray off the end here and onto the rotor. I'll bend that down a bit, there we go. So the charges just spray out and get sucked up onto the rotor, because the rotor's it's all explained in this off. It just screws in with full. I've shown you a close-up of it. It's just a disc. I've cut little sectors. I've put it on, and then I've cut it out with a Stanley knife. So I've stuck a bit on, cut it, stuck a bit on, cut it. And it comes around this edge. There's a groove cut into the side of the edge, and I'm taking the charge off the sides, so I don't have to worry about touching the top. So here's my little post. So you just print these up. Screw in the bottom here. One's a left and one's a right. But these pieces here are identical. It's just because of the curve that's inside here to allow for this curved plate to come around. So you print them up, it sits on this plate here, and they just slide in. And it just allows everything to slide in and slide out, cassette type, if you don't know what a cassette is. And the only thing we had to do is we had to run a bit of conductive foil on the post, so the top piece and the bottom piece are joined. When I've lacquered them, this post, hold it up, this post is going to go in here, like this. So I haven't put any lacquer or any insulation around on the first section here. I've heavy insulated this section here. And I've cut it away from the post because the wire, I don't want the earth wire to be shorting out on this plate. That's where you lose your charge. And they wind up sitting in there pretty good, so I'm just using little screws. This is the little screw I'm using. I don't know if you can see that. So the way I'm doing that, I've got my trusty, let's cut a little bit off. So this is sticky, this is conductive both sides. Doesn't really matter how rough you are inside of this, because the charges are going to want to be on the outside anyway, charge disc or whatever it's called. Righto, so here's the top one. Top one goes in there like that. Line up your holes on the back. That's pretty good. You just have to clean up your brim. Using more PET G these days instead of PLA. So you know. So I'll do that up. And my foil in there, I'm just going to use a screwdriver to flatten him out. And I've got to poke a little hole in it, so I'll just push it on. The rougher that is, the better. Because when the wire comes through, it'll help it connect. And no charges can leak from in there anyway. So they want to move these parts. Took me a while. I should have cut the sharp edges off. Don't have any sharp corners. When you do when you cut, this is a capacitor plate I'm making, but you cut your corners off. And I keep forgetting to do it. Look at this one, I've made a mistake. I did 10 of them, 12 of them. Look at this. Sharp corner. Made a sharp corner, that's no good. Blew a hole straight through it. Righto, so that's that one. And now our wire, where's my wire? Oh, here it is. So I've just got soft, as soft as I could get it, bit of wire. And I've put that in there. And it can point back a bit. I've twisted two wires together, one's soft and one's firm. And it can point back a bit. So I can drag around with the rotor a bit, it doesn't matter. Won't make a difference, so that just slides in there. There's the equalizer wire. Let me get that out. That's a bit of a problem, but anyway. It's hard, what can you do with that? So here's our wire. And taking through. That's it. Once it starts to run and get some charge on it, the wires don't have to touch. The charges will jump off. So here's our equalizer ring, and all I've done is I've got some little bits of wire. I've got one piece of wire that runs around the top, and I've joined it with the tape. I've put the copper conductive tape on, and it's touching. And yeah, we got 0 kilo ohms resistance. A little wire goes on top. Boop. And this one, I wonder why I didn't use short screws. Maybe I made a mistake with the holes. I've used sort of slightly the next length of screws for the top here. And there's a bit of wiggle room with this. But what's going to happen is the disc, there's a bit of wiggle room. It'll slide in and out. What's going to happen is that disc is going to, right, so it's done. These just go in the holes here. Now these things, you don't want them to they only just poke through a little bit. There's your big, they can discharge your capacitor plate, your collectors. Anyway, that's it. So, put our lid on, and we've got our little lid. Lid goes on. Now I've adjusted all these bolts before, and I've put a little bit of glue on them. Just a little bit of wood glue, so they shouldn't, oh, they do turn. They're not supposed to turn, but anyway. So I've put a bolt in the middle where I want it, and then I've put these bolts on, I just do that. And this is it, this is our last video together. Well, second last video. I'm thinking about doing, I wasn't going to do the transformer, but I should do the transformer. It will give me an idea on how big I have to make the next machine. I mean, ultimately I'm going to make the next machine as big as possible. I just like making machines, but you learn so much. I've learned so much about engineering and design and a few other things. Electricity, capacitors. Let's see if it's telling the truth. Using a Toppler Holtz is if it overcharges or goes through, you have a problem, it'll backfire through the Toppler Holtz and it won't wreck your machine down here. If you do it the other way, you run the risk of blowing up down here. But I need to be able to reverse the charge. It'll only run for a few minutes and then it'll overcharge. And you need to discharge it and run it the other way. But, you know, that's a good thing, eh? It just works. So anyone should be able to build this and get it running without any problems. Oh no, that's what I'm going to do. I'm going to put a spark gap here. I forgot about that. So I'll redesign that. I'll design that and put it in now, because what we need to do is we need to set a spark gap up here, so if it does overcharge, bang. See, it's built up charges and it's caused a bit of a problem. Alright, here we go. I've set it up. Here's the tool I'm cutting it with. I'm just going to take a little bevel off the end there, and this is what we want to end up with. This type of smooth ends. Well, here we go. We've got the new spark gap going, and it should just TopplerHoltzMachine. It's still breaking down internally a bit, so I'm going to have to find that. So what I can do is I can tighten up the spark up a little bit. I'll put little rubbers on the end so I can touch it without shorting it out, and hopefully it'll break down here instead of breaking down in the back of the machine, and protect the I should have had this from the beginning. Oh, there it goes. And with the capacitor, I'm hoping it leaves charge on the plate down here somewhere. All there's inside the capacitor just arced over. Oh, maybe I'll have to check it. It might be the faulty part. It's discharging through the capacitor. So my little spark gap. There it is. That way I can just discharge without getting too fully discharging, because a decent gap should leave a few volts on the bloody plates. There we go.